In this lecture, we will see the layout of a 2-input XNOR gate that is drawn from the twisted schematic diagram. Now, in order to open the terminal window, press Ctrl Alt and T, then type magic, then press enter. Now this is the layout window and this is the tick icon window. So at first we will see the layout by using the commands. In order to grid in, type grid, press enter. If you want to zoom in, press Z. Now in order to draw the layout of a 2-input XNOR gate, we need 2 inverters and 2 transmission gates. Since we are drawing the XNOR gate using transmission gate, so we need 4 PMOS and 4 NMOS. In order to draw the PMOS, select the area, zoom out, select the area and type paint anvil. Okay, now there will be 4 P diffusion. So this is 1, paint, pdiff, this is 1, then this is the second one, then the third one. You can just give a bit more gap. So we need some more space up to here. Select from here to here and type paint anvil. And again select the area and type paint pdiff, zoom out. So you can see there was 2 width over here, the spacing between the outer line of anvil and the P diffusion. So just in order to maintain uniformity, have to select this and type erase. Okay. Now after drawing the P diffusion layer, that is the P diffusion PMOS, next is to draw the NMOS. Now type paint and diff, and diffusion, paint NDIV. Now just in order to get uniformity, you have to place it similar gaps. Okay. Now the first two PMOS and NMOS, they are meant for drawing the inverters, and the last two are for transmission gates. So in order to draw the inverters, first you have to draw the gate, that is the input. Zooming in helps us to find the width or draw according to the width. So this we have taken as 2 lambda. Okay, we can place over here. Okay. Now paint poly. Then again paint poly. So for uniformity again, here it is 2. We can even make it to 1. Erase. Similarly over here, erase. Now complete the inverter first. So these are the gates. So this is the source of inverter 1, this is the source of inverter 2. So we know that the sources of the PMOS are connected to VDD. Okay, now type paint M1. Similarly over here, we can make this connection again from here to here. Okay, instead of drawing over here, just increase to here. Paint M1. Okay, now of the same length you can take the ground. Now type paint M1, or you can even take off lesser width, type paint M1. Then similarly over here, then over here. So these are the sources of the NMOS which are connected to ground. Now the input is given through gate and the output is obtained from the drain. So connect the drains of PMOS and NMOS. So type paint M1, then again over here M1. So the inverters are already designed. You must be thinking why this VDD, it has been drawn with so much gap. That you'll see later on. Now after drawing, we can first label it. This is the input. So draw a square, then right click, type label A, or I can say VA. This is bar. So label VAB. This is second input B. So label it as VB. Let me undo. It is just VB. Got a single quote. Now this is label VBB. Okay. After this, after labeling the inputs, you can also label the VDD. So label VDD. And then label ground, that is GND. Okay. Now after labeling, if we want, then we can place the contacts also, but we'll place the contacts later on. We'll first draw the transmission gate. So we know the gate of first PMOS is connected to the gate of second NMOS. The gate of second PMOS is connected to the gate of first NMOS. So I have to basically connect. Now type paint poly. Before that, now type paint poly. Okay. Now from here to here, okay. Similarly, you have to select this part. You have to connect this gate, the gate of the first NMOS to the gate of the second PMOS in the transmission gate. So we can do this like this. Then type paint poly. Increase it. Okay, now type paint poly. Up to here. Paint poly. Okay. zoom in and then connect these two. Okay. After connecting the gates in a transmission gate, the sources and the grounds are connected. So you can directly make a selection over here and place it over here. Then type paint M1. Similarly over here, paint M1. Type paint M1. Similarly over here. Now after connecting the sources and the grounds, these two are the drains, these two are the sources. We know that the drains are connected to the output. Paint M1. Paint M1. Okay, now this is our output. This source terminal is connected to B, that is this VB. So how to that? Sorry, this is connected to B bar and this is connected to B. So if this is connected to B bar, then this can be directly connected from here to here. Isn't it? Paint M1. So this VBB is connected here. Then this B is connected to this B, this one. So type paint poly paint M1. This is paint poly, then paint M1. Paint M1. This is the overlapping between the poly and the metal one. So paint poly contact. You can see this metal is connected to this poly. So this is VBB, this is VB. These two transmission gate drains are connected to output. Now the gates of the transmission gate, they are left unconnected. So the gate of the first transmission gate is connected to A bar. So we can directly take it from here, A bar. Okay, this first one is connected to A and the second gate is connected to B. Sorry, second one is connected to A bar. First one is connected to A and second one is connected to A bar. So when we talk of second gate, that is this one. This is connected to A bar. So take it from here, then type paint poly, type paint M1, type paint M1, paint M1, then type paint poly, then type paint poly contact. Okay. Now A bar is connected, that is VAB, and if you want to connect A, it is connected to the first shorted gate. So just take from here, type paint poly, then type paint poly again, then connect from here to here. Okay, this is connected to this gate, this is connected to this gate. Once you've understood the schematic, then the twisted schematic, then it's very easy for you to draw the layout. Okay, before going to contacts, we can label the other terminals left. The other left is only the output. So this is the output. So select, right click, and then label V out. Now I have to place the contacts. So select the area, type paint. This is P diffusion contact, so type PD. Since this is a P diffusion layer, so type paint PDC. Paint P diffusion contact. This is the second one. Then again paint PDC. So there will be eight P diffusion contacts. paint PDC, then okay, then next place the end diffusion contact. First place the diffusion contacts and we can place the substrate contacts. Paint NDC, then one over here, then here, now if you zoom out and see, if you need the substrate contacts, this is ground VDD, so you need the substrate contacts. So zoom in, then zoom in one more, type paint N well contact. Similarly over here, paint N well contact. Similarly at the ground, type paint P well contact. Here also type paint P well contact. Okay, now we have placed all the contacts. Zoom out, all the contacts are already placed. Okay, now save the layout as save. This is XNOR, so XNOR 1. Then find DRC. That command abbreviation is ambiguous. Sorry, it's DRC find. So there are no errors. Then extract. So XNOR1.ext generated. Then extract to sim and extract to spice, which is not needed much. So once the sim file is extracted, open irsim. The file name must be xnor1.sim. Press enter. We have two inputs, one output. So watch VA, VB and Vout display. All are X. If I give low value to VA and VB, my output should be That is when inputs are 0 0, output of XNOR is 1. You can see output is 1. When both are high, again it will be 1. Okay, before that, okay, let's see. It's 1 again. When both are different, so the output is 0. Okay, then give low value to VB and high value to VA. Output is 0 again. So if you want to say this in an analyzer, type ANA, VA, VB and Vout. So you can say this 001, 111, 010, 100. So you can see all the combinations. You want to exit, then type exit. If you want to see the layout again, then type magic XNOR 1.mag. Then zoom in. Okay, so this is the layout of a 2-input XNOR gate. We have drawn the layout by using 2 transmission gates, 2 inverters, and the layout is drawn using commands in magic. Now let's see the layout of a 2-input XNOR gate from the untwisted schematic by using the toolbar in magic. At first, open the terminal window by pressing Ctrl, Alt and T. Then type magic. Now in order to load the toolbar, go to options, then click on toolbar. Now in order to grid in, press G. In order to zoom in, press Z. Now in order to draw the untwisted schematic, the layout from the untwisted schematic, we can draw the gates in this form, the N-well, then the P-diffusion, or according to our schematic, untwisted schematic, we'll draw the N-well as in this form. Now click on N-well. Similarly, we need a P-diffusion layer. So select the area and then middle click on P-diffusion. This is the P-diffusion. So middle click on P-diffusion. Of the same area, we also need the N-diffusion layer. So middle click on N-diffusion. Okay. Then this is one transmission gate. So we need another transmission gate. Middle click on N-well. Select the area and this is P-diffusion. then middle click on end diffusion. Okay, now before shorting the gates of this PMOS with this NMOS and this PMOS with this NMOS, you can see this is one transmission gate and this is the second transmission gate, and the gate of individual transmission gate is connected, the gate of one PMOS is connected to the gate of the second NMOS, and the same case with this too. So first connect the gates. Width is 2. Okay, now middle click on poly. Now before connecting the gates, we can draw we can short the sources and the drains. So these two sources are connected, then middle click on M1. These two drains are connected, middle click on M1. Similarly over here, middle click on M1, these two sources, and for these two drains, middle click on M1. Okay, this is just a rough sketch. Okay, now we need two inverters, two transmission gates are done. Remember, the gates are not yet connected. So draw the two inverters. You have to draw the two inverters. So middle click on N-well. This is one. This is another one. Middle click on this N-well. Then select this area and middle click on P diffusion. Similarly over here, middle click on P diffusion. Then we need N diffusion layer. Middle click on N diffusion. Middle click on N diffusion. Now then middle click on poly. Similarly we have middle click on poly. We can simultaneously connect these two also. Okay, now connect from here to here. Again middle click on poly. Have to undo this. Okay, now the gates are connected. These two VDD are connected to these two sources are connected to VDD. then and this to connected to ground. Okay, now these two drains so there's not good uniformity. We can do one thing, we can just extend this layers just for uniformity. This is anvil, P diffusion. Okay, now connect these two drains, middle click on M1, middle click on M1. Now connect the, now you can connect the gates. So this gate is connected to this gate. Middle click, middle click on M1. This is connected over here. Okay, before that, let's name it, label it, label VA, label VB, this is label VA bar, and this is label VB bar. Okay, now this gate, these two gates are connected to this A. So we can directly connect from here to here. And then middle click on M1, middle click on poly. Directly this can be drawn. Then from here to here, erase. Okay, now this is VA, A connected. Now A bar. This A bar is connected over here. So from here to here. Middle click on poly. Middle click on poly. Basically, we're trying to connect. Trying to connect to a bar. Now to just zoom in. Then middle click on M1 and middle click on poly. And since this is a connection between metal and poly, so we need to place a poly contact. Okay. Now this is VB. Now this VB is connected to here, and B bar is connected to here. So this is B bar. We can do one thing, just erase and place it over here. Then middle click on M1. Again middle click on M1. Okay. So here to here connected. Now VB is connected to here. So middle click on M1. So this just got connected to here, or we can have done reverse way, that is directly from here to here. While drawing the layout, we should always keep in mind about the uniformity. So I think this looks better. Okay. Now we have to place a contact over here, that is the poly diffusion contact or the poly contact. Now all the connections are completed. We have to label the inputs and the outputs. Inputs are already labeled. This is VDD, label VDD. Label ground. Now, okay, the output. This is the drain. Middle click on metal 1. So this is the output. Instead of drawing so much, we could have directly joined from here to here also. So if you want, then just undo. Directly from here to here. It's the same thing. So this is the output. So type label Vout. Now we have to search for the polydiffusion contact. Select the area, then middle click on PD contact. Similarly over here, the PD contact. This is the end diffusion layer, so ND contact. Okay, at first I can middle click on metal 1 and then on the ND contact. Then over here the P diffusion contact again. Similarly again M1 and the P diffusion contact. Okay. In the VDD layer, can place one and substrate contact, and the ground you have to place two P substrate contacts. No space here, so we can leave it. Then over here the PD contact, again the PD contact. Over here the end diffusion contact, here the end diffusion contact, PD contact, PD contact. Okay. Now you can see all the contacts are placed and the layout is completed. Now type save XNOR 2. You can find the DRC errors, no DRC errors in XNOR 2. Then extract, that is extract the file .ext. Then type extract to spice and then extract to sim. Okay, now the sim file is extracted. Now type irsim XNOR 2 dot sim. Then type watch VA, VB and Vout. Then type display D. So you can see the values are X, X and X. Now give low value to VA and VB. What should be the output should be 1. Now VA is already 0, give high value to VB, output will be 0. then high value to VA and low value to VB, the output will be 0 again. H value is already given to VA, then give high value to VB, the output is 1. This is the truth table of XNOR gate. 0 0 and 1 1, the output is 1, and for all others the output is 0. Type A and A, VA, VB and Vout. Can see here perfect timing. It's 0 0, it's 1, 0 1, output is 0, 1 0, output is 0, 1 1, the output is 1. If you want to exit, then type exit. If you want to see the layout again, then type magic, XNOR 2.mag, press enter. Now zoom in. This is the layout of a 2-input XNOR gate that is drawn from the untwisted schematic. You can see this is one transmission gate, this is the second transmission gate, this is one inverter, this is the second inverter. The inputs are VA, VB, the output is Vout. This is the layout of a 2-input XNOR gate that is drawn using 2 transmission gate, 2 inverters using the toolbar in Magic. Now if you want to see the spice file, then exit from here, type exit and type vi XNOR 2.spice. So you can see here it's written spice3 file created from XNOR 2.ext. The technology used is SCMOS. Scale is 1U. This is M1000. M stands for MOSFET. This is the first PFET, that is the first P MOSFET. The W by L ratio, that is W is 6, L is 2. You can see the first two P MOSFET have same W by L ratio, which varies from the third P MOSFET. It's 7 and this is 2. Then this is the fourth PFET, that is 7 by 2 W by L ratio. If you remember, the 6 by 2 ratio, that is a W by L ratio 6 by 2, there are 2 P MOSFET and the next 2 P MOSFET have the same W by L ratio. Now this is VDD, VA, VAB. This is the first P MOSFET. Then this differs with the second, similarly the third and the fourth. This is AD. AD indicates the area of diffusion, that is 72, and the perimeter of diffusion is 48. The area of substrate is 42 and the perimeter of substrate is 26. Similarly, in the case of N MOSFET, the W by L ratio of 2 N MOSFET is same. You can see here this one and this one, and the W by L ratio of these two MOSFET are same. That is 6 and 2, 6 and 2. But there's a variation in the area of diffusion. You can see here the area of diffusion is 72, but in this case it's 0. Similarly, it's 140 over here. Again here it is 0. Same way it's with the N MOSFET. Here it is 140, then next it is 36, and for the rest two it is 0, 0. This is C0, C1, C2. If you want to exit, press colon and WQ.